In this tutorial we're going to take a look at actually animating particles, making them move around the screen. And a lot of the principles that we're going to look at here will, in this tutorial and the next few tutorials, would also apply to animating everything. So in SDL, at the moment we're doing pixel access. We're putting a load of particles on the screen, which are just individual pixels. But SDL also allows you to put images on the screen, which we won't look at in this tutorial. But you can animate images in the same way that you can animate particles. So at the moment what's happening in our main program here is we've got our game loop. So even though at the moment that the particles are not changing position, although they are changing colour, we're redrawing them as often as possible. And usually for a game or a simulation like this, you hope that your game loop will execute at least sort of 25 times a second. I would guess here we're getting more than that. I don't know how many, 30 or 40 redraws a second probably on my computer here. And I think I'm building a debug target as well, which will always run more slowly than the release target. Actually, since we're not going to do any debugging, I can probably go to project and build configurations, set active, and go to release, because that will compile a version without debug symbols in. And I haven't shown you how to use the debugger, and we're probably not going to get onto that in this tutorial on basic C++. So we'll build a release one, because without the debug symbols in it, which we're not using anyway, it will typically execute quite a lot faster. So now, just to get us started with animation, let's see if we can make the particles bounce around the screen sort of randomly, which is not the final effect that we want to achieve, but it would certainly be a bit more interesting than having them just sit there. So since we're redrawing the screen at least probably 30 times a second, all we have to do is move the particles in between redraws. Well, actually we'll need to clear the screen and then move the particles every time we redraw the screen, and that will give the illusion of movement. So let's go to particle.h here actually, because I want to give particle a method which I'll call update. Let's make it void update, like that. And this is going to update the position of the particle and ultimately probably the color as well, but we'll leave that for the moment. And then we'll go to particle.cpp and create that method here. So we've got void particle : update. So in here we can change the positions of the particles. Let's just check what this error is here. Did I put that in the wrong place or something? So we've got void update in particle.h, and I'm editing the right particle.h, and it's for some reason complaining that's not right. Let's try just building it. Maybe I've got the wrong particle.cpp. Yeah, for some reason I put that in the wrong particle.cpp. Let's cut that from there, save everything, quit that, and try putting it in the right file. I should really close these projects as I go along, so it does get confusing. Okay, that's better. So what we can do in here is let's create a constant here. Let's say constant double speed. Yeah, let's just have a speed and set it equal to some like quite small value, like 0.01, and every time we call update, which I need to call somewhere, I'm going to add speed to the x and y coordinates. Let's say m_x plus equals speed, and m_y plus equals speed. Now this isn't very good because they're all going to move in the same direction, but let's see what effect this actually has. Let's go to our main file here, and before we draw the particles, let's call update on each of them. So Maybe I should do that. Yeah, what I can do is I could call update on each particle at this point after this. But in fact, what I'll do is I'll go to swarm.h and I'll also give swarm a void update method. I won't make it virtual because I'm not planning to override it. And go to swarm.cpp. Let's have a void swarm : update. And in there, I can loop through all of the particles with a loop like this. So it would be more efficient, I suppose, to update each of the particles' positions in this loop. But because at least this computer doesn't particularly struggle with this, I'm going to go the route of more elegant coding rather than greater efficiency and create a separate loop to do this. So I've copied that loop where we loop through all the particles in the main sort of thing. And here I can say for each particle, m_p particles and the array brackets here, I.update. So I'm calling update on each particle. It's complaining about that for some reason. I'm not sure why method update could not be resolved. But I have added it, particle. Oh dear, I think I'm editing the wrong swarm.cpp as well. This is really a disaster. Let's cut this out of here, put it in the right place, and save that. And let's check my swarm.h. Yes, I also edited the wrong one there. Let's save that, go back to swarm.h, and put that in. If I do this again, I think I'm going to re-record the video, but sometimes I like to leave these mistakes in just so that you can see what kind of thing typically goes wrong, at least with me, because I'm sure you'll make many of the same mistakes. But let's close that project now. Okay, so we've got swarm.cpp here. The error's gone away now. We're updating each particle, and now in main.cpp, when I do each of these loops, I can call, I'm going to put it down here for reasons that I'll show you in a bit. Let's call swarm.update to update the positions of all of the particles. So we've got our update code in our particle.update here, and let's see what happens now when we run this. So let's check it out. So now all the particles have shot off in the same direction. We're not getting any errors because we've made sure that we're not drawing pixels if they go out off the edge of the screen. Otherwise this would crash our program, but we've taken care of that already. And you can see it's leaving these trails because we're not clearing the screen in between drawing these particles. So let's think about clearing the screen. If we go to screen.cpp, we've got an update method here, and that's clearing the renderer, but it's not clearing the particle buffer where we're drawing the particles. So if you remember, when we draw our particles, we're actually using screen.setPixel, and if we look at that, that's drawing into this buffer which we're not clearing. So the thing to do is that we need to clear this buffer somewhere. So if we look at main, first we're doing set pixel and then we're doing screen.update. Probably the right thing to do here is to create a screen.clear method. Let's try that and see if that works. I think that might do the trick, because there's nothing else here that we can really clear, I don't think. So let's try that. Let's go to screen.h and add here a void clear method, and I'll go to screen.cpp and implement that. Doesn't matter too much where we put it, so screen clear. And in there I'm going to do memset. We're going to memset the buffer that holds the particles. So we're going to memset each byte in there to 0, just to sort of clear it. And the number of bytes is going to be the number of bytes of the buffer, which in fact actually we've already got exactly what we want here. So we did clear it when we initialized it. So it's the screen width times the screen height, because it holds actually 4 bytes for each pixel in the screen, times size of uint32, which is 4 bytes. Let's just copy this line, in fact, 'cause it's going to be a bit quicker. Paste that in there. And then if we go to main.cpp, before we draw the particles here, we can clear the screen. So we can say screen.clear somewhere up here. Now let's see what that does. So let's run this. And now we can see that we've cleared the screen and we've just got a massive load of particles that just all shuffle off to the lower right there. So the reason they're doing that is because if we go to particle.cpp now, we can see that we've got this speed and we're just adding that value to the x and y. So if you increase x, it will move the particle to the left. Let's just demonstrate that, for example. We run this and we see the particles moving, to the right. And if we increase y, it actually moves them down, because y increases from the top down to the bottom of the screen, which is how the screen is actually redrawn. Hopefully you can see that on this video. And if we do them both at the same time, then the effect is to move them diagonally down to the right and to the bottom. Well, that's not very good. What we'd really like is we'd like them sort of moving randomly around a bit. So what we could do is we could have a, let's say, const double x speed, and we need to set this to some random value. Let's use rand divided by rand max to get a random number between 0 and 1. And this, remember, rand max is rand returns a random number from 0 up to rand max, and rand max is some big constant here. It's this, in fact, 0x7 and a bunch of f's in hexadecimal. And remember that these are 2 integers, so this would give us something not useful at all. That would give us 0 probably, I suppose, usually. But if we multiply this by a double, if we multiply rand by a double, then we'll do double division instead of integer division, and we'll get some useful result. So let's try this. And we can do the same to create a y speed as well. So again, we'll get another random number from there, multiply it by a double. I meant to put these brackets just around the top bit here because we want to make sure that we're dividing a double by an integer, because as long as we do this bit of the calculation first, we've got a double, and then when we divide by this integer, we will still do double division. As long as either the numerator or the denominator are a double, you get floating point division, which is what we want. So now we can add x speed to x and y speed to y, and let's see how that looks. So we're still getting them. In fact, are they even moving at different speeds? I'm not completely sure. They should be, but they're still shuffling off to the bottom right, which is not really that interesting. So we should be getting different speeds here, though. What we can do is, what we really want is, yeah, you can see they're jiggling about as they move, but on average they end up moving with a sort of similar sort of average speed. To make them move in different directions, we want to make sure that x speed and y speed can be negative as well as positive. So rand divided by rand max, that's giving us a random number between 0 and 1. What we really want is a random number between -1 and +1. So to do that, we can increase the range of this by multiplying it by 2. That's a random number from 0 to 2, and then subtract 1 from it, so subtract 1. So we want to get this in the right order. Let's just cut this down a bit. So we want to multiply 2 by rand, 2.0, that's very important to turn this into a double. Divide it by rand max, so that will give us a random number from 0 to 2, and then subtract 1, which will give us a random number from -1 to +1, and that's what we want. And once we've got that, let's put more brackets around this, we can multiply it by some speed constant that can determine for us basically roughly how kind of fast that we want them to move. So let's paste this in for y as well, and we've got some sort of warning here. This is just this bad character sequence which plagues me, but I can see that there's a space underlined, so there's obviously some weird non-printing character instead of a space, so I've just deleted that and put a space in. Now let's run this again. So now we're seeing them jiggling around in quite random ways. Now they're behaving like flies. The average speed of them is 0, because we recalculate the average speed every time we draw the particle. What would make it more interesting is if we gave the particle its speed, its direction, when we initialize the particle, and if that each particular particle then stuck to having the same speed and direction for its entire life. So what we can do is take these out here, let's cut them from there, let's go to particle.h and paste them in here. Let's call them m underscore x speed, m underscore y speed. I can't initialize these here, so I'm going to get rid of the const here. I'm going to copy this into the constructor of the particle. So get rid of the declaration from the constructor, like that, and get rid of the assignment from the header. So get rid of this bit which we can't put where we declare the variable. So I've declared the variables as well, the public variables, but it doesn't matter for the moment, in the particle class, and in the implementation in the constructor, then I assign the speeds to random speeds, and then we can simply use them in this update method here. So now if I run this, we see something much more interesting. The particles are buzzing around, and they're gradually all going to move off the edge of the screen and get lost. Now this isn't the final movement algorithm that I want to show you, because it's a kind of a bit boring for our purposes here, but I wanted to show you some of the basic principles of animation. One last thing that I want to show you is we can make sure in this update method that the particles don't move off the edge. So let's say here if m underscore x is less than 0, or if m underscore x is greater than screen width, really we should say is greater than or equal to screen width, then we'll make the x speed equal to the negative of itself, so that we reverse the direction in the x direction of the particle. So if the oh sorry, that should actually be 1, because we've said that the particle is bouncing around in a box that goes from, and this should be -1, come to think of it. Yeah, so we're making the particle bounce around in a box from -1 to +1. So if it exceeds those bounds, then we're going to change the speed. We're going to reverse the speed. So we reverse the x direction by taking the negative of itself. And we don't have to worry too much about whether it could go off the edge of the screen, because if the particle's already off the edge and we change the speed, then it's still off the edge, because the speed will only affect it next time update is called. But we don't have to worry too much about that, because we've made sure that pixels can't be set off the edge of the screen, which could cause the program to crash, so we don't have to worry. Let's do the same thing for y as well. So if y is outside of this box of -1 to +1, then we can change the Y speed to the negative of whatever it is currently. So if it's positive, we make it negative. If it's negative, we make it positive. And if we run this now, we can see that now the particles stay within the screen and they're all just bouncing around randomly. Might be nicer if there was less of them and they were a bit slower, actually. Let's go to where we initialize the speed here and make it slower. And I'm also going to go to swarm.h and change the number of particles to 1,000. So now we'll run this. So as I say, this isn't the final algorithm that we're going to use, but it shows you the basic principles of animation, and you can use this kind of thing for making a ball bounce around the screen, for example. So I'll leave it there for now, and we've got some more things to do, including blurring the screen and making the particles move in a much more interesting way. So we'll tackle one of those in the next tutorial. That's it for this tutorial.